Hello, friends. Welcome to the ATC Double Cut. In this episode, let's talk about surface hardness or firmness of some different turfgrass surfaces. This is a topic that I've gone into the archives for to find a blog post. This is one that I wrote, I think, back in 2014, maybe a little bit more than a decade ago. I've been doing turfgrass research and studying turfgrass, observing turfgrass, and writing about it for a long time. And I last updated this post in 2021. So I will put a direct link to this in the show notes. This is a blog post on the ATC website that has a title, Measuring Surface Hardness on Greens, Fairways, and Approaches. And I started off by writing this paragraph. I measured soil moisture and surface hardness on 3 fairways, approaches, and greens at a golf course in Thailand in September 2014. The fairways and approaches at this site are Seashore Paspalum on a sand cap. The greens are Ultra Dwarf Bermuda grass on a USGA green. Now, what a sand cap means in Thailand generally is a relatively coarse sand material that will be about 6 to 8 inches usually across the fairway. So when the course is built, it will have 6 to 8, maybe a little bit less. At a higher budget place, it will have a deeper sand cap. And they do that so that it can, like a sports field or like a USGA green, so it can be easily playable soon after torrential rainfall. And so this is a situation where we have a sand-based root zone on greens, a sand-based root zone on fairways, and a sand-based root zone on the approaches. And I wanted to check what the firmness was, and I wanted to check how that was affected by soil moisture. And if we go to any single site and measure this, we can get a very nice relationship between the soil water content and the surface hardness. So I showed the information in a chart where I plotted the water content of the root zone on the horizontal x-axis. And the lowest water content was about 12% and maybe about 15%. And that was on the putting greens. And then the fairways and the approaches had a water content that ranged from about 25% up to 50%. So 50% would be saturated. How does that happen in a 6 to 8 inch or a 15 to 20 centimeter very coarse sand cap? Well, it happens when there's a lot of organic matter that accumulates near the surface. And on a putting green, the way that the putting greens at that course are managed, that putting green gets regular top dressing, the putting green gets core aerification, and the putting green gets solid tine aerification, and again, regular sand top dressing. So those maintenance practices keep the organic material from getting too high at the surface of the putting green, and that allows it to maintain its firmness while the fairways and the approaches do not get anywhere near the same amount of sand top dressing. They do not get the same amount of cultivation work, and because of that, the organic material tends to accumulate on top of the sand root zone, and that leads to wetter surfaces and also to softer surfaces. In this case, I measured with both a Clegg hammer, my 500-gram golf course firmness tester from SDI in the UK, and as I've mentioned previously, the average value in my data set of thousands of measurements, the average value for non-tournament conditions is 87. So I would say that anything above 87 with that device is a little bit firmer than average. Anything lower than 87 is softer than average. And at this day, at this golf course in Thailand, the putting greens were testing in the 90 to 100 range. So in the range of about 15% up to 25% soil moisture, the greens were testing a little bit firmer than average. And then we were getting scores of 80, 70, down to about 65. The lowest was a score in the fairway of about 65 that also corresponded with more than 50% soil moisture content. So there's a lot of organic matter. That organic matter is holding a lot of water, and then those surfaces are very firm. I also use the True Firm. In this case, it was the True Firm that's available from Spectrum Technologies, and now the scores are in hundreds, which I think is something similar to 1/100th of an inch. And in this case, it's measuring the depth of the depression, or it's estimating what the depth of the depression of dropping the cylinder onto the surface, what the depth of that depression would be. So in that case, a deep depression would have a higher number, meaning it's softer, and a lower number would be a depression that's less deep. The cylinder would drop into the surface less. In this case, the results were similar to what I found with the Clegg, in that the greens were the firmest at a value of around 400 to 500. And then the fairways and the approaches went from about 500 up to 650, meaning that they were much softer. And in this case, this is the type of situation that you can find if you go to like a single property and measure this. You can find a really nice relationship between the surface hardness and the volumetric water content of the soil. If it gets complicated when you start checking this across multiple properties. Let me see. I may have another blog post that was a bit of a mess about this. Yeah, let's see. That's not showing on the screen right now. And I don't know if I can pull it up. Yeah, we'll talk about that in another episode. I think I've just been having so many conversations about this. Oh, sorry. Now it's showing on the screen. All right. I know a lot of you are listening to this, so I'll describe what this is and then say that this is going to be a topic for a while, because I've been having a lot of talks with people about firmness and about top dressing sand and about soil water content, and if there's things that can be done to in choosing sand types and so on that will have an effect on firmness. This is a blog post that I also updated in 2021 that has a title, Relationship Between Soil Water Content and Turfgrass Surface Hardness. And if we measure the surface hardness of a green, it's often related to the soil water content. So if you think about the things that allow you to manage the soil water content, it's going to be affected by the water holding capacity of a sand and by the organic matter content. So when you have more organic matter near the surface of a green, it's going to tend to hold more water. When you have less organic matter near the surface, you will tend to have drier surfaces, and those drier surfaces will be a little bit firmer. And so what you need to do is figure out how much sand is necessary in order to keep the soil water content range that your greens or your fairways or your approaches or whatever or your sporting surface, whatever type of surface you're trying to produce, you want to make sure that you can manage that soil water content. If you can manage the soil water content to the desired level, or keep it within the minimum and maximum range that you know is going to produce a certain firmness level, then you will achieve that type of desired firmness level. And so it's not so much, well, yeah, the sand is linked to the water. So you have to put some amount of sand or the surfaces will tend to get too much organic matter. And if the surfaces have too much organic matter, then they will be too wet and the surfaces will not be firm enough. So you want to be looking at things like sand and at your organic material right at the surface. That's where the OM246 testing is so useful. And courses that are producing some excellent surfaces with really commendable firmness, with firmness that is a little bit higher than expected or higher than average, they are making such good use of OM246 data to calibrate how much sand they need to apply in order to keep the organic matter at a level which will then allow the water content of the soil to be managed at a level that allows the firmness of the surface to be managed at the desirable level. This is something that I've studied quite a bit over the years and made a lot of measurements about. I know there's other research going on in this same area, and the results that I've seen so far are very, there's nothing too surprising in that if you top dress at a suitable amount, that's when you get the maximum firmness. And if you cultivate the surface and punch holes in it, it makes things softer. So you want to minimize cultivation and you want to put the right amount of sand. And whether the actual type of sand matters, there's not so much evidence that that's the case. I've been looking into coefficient of uniformity quite a bit. I know some of you will have heard me talk about it, and that's something that's coming for the future to discuss that more. I'm just not finding that coefficient of uniformity of the sand has too much to do with the firmness of the ball reaction. So we can find instances where it seems to, but we can also find instances where that doesn't seem to be the case. So here's a little tip. There is a surface hardness tag on the ATC website blog posts if you go to either of these that I'll link to in the show notes. So this one is relationship between soil water content and turfgrass surface hardness. The other one that I talked about, whatever I started with, I'll put a link to that in the show notes also. I'm not going to change my screen for fear of having the screen go blank again. And then if you click on that, you can find so much information, all kinds of reports and other blog posts where I've discussed surface hardness or surface firmness. And that is something that is a hot topic in the world of turfgrass these days. And I just want to remind everyone that I haven't been writing about that a huge amount recently, but there are a lot of posts on the website from back in the 2011, 12, 13, 14, 15 type of era that you can access by clicking on that surface hardness tab and finding some of that information. All right, that is enough for this episode. I promise to be back again soon with a bit more interesting turfgrass information. For now, I thank you for listening and for watching, and I'll sign off for ATC from a small island in southern Thailand. I'm Michael Woods. Bye-bye.